Hello and welcome to the video lecture on how to use a KEIL software. In my previous video, I have already explained how to download and install this KEIL software, KEIL Microvision file. In today's video, we'll see how to use this KEIL software. So this KEIL Microvision is basically a free software which basically solves the many problems for the embedded program developer. So without connecting any hardware, you can write your code and also you can simulate your code using this KEIL software. This software is basically an integrated development environment called as an IDE, which has an integrated text editor for writing the program. There is a compiler which will convert your source code into the hex files. So basically why it is called as an integrated development environment, because you can create the project, build your project, run it, debug it, all you can do this under the same window. Okay, so that's why it is called as an integrated development tool. Now we'll start with this demo of the KEIL Microvision file. So for that, first you have to click on this KEIL Microvision icon on your desktop. Then if there is any project open, then you first to project tab and close your project. Okay, I will show you all these steps now. Now here you can see there are various icons like file, edit, view, project, flash, debug, peripheral, tools. So file is nothing but it is similar to our normal file icon. So if you click on it, then you can see that there is an option new for creating a new file. You can open already created file, you can save it. Okay, and all the created files you can see over here. That is what is the list, and this is the exit. So file menu is like our normal file menu. Sorry. Then you have the second, that is edit is also similar to the other tools. Then you have a project icon. So that project is very important. You have to, whenever you want to create any new project, you have to click on this project. Okay, once you click, there are various options. First is new microvision project, then new multi project workspace, open project. Okay, so in that, whenever you want to create a new project, you have to click on new microvision project. So this window gets open. So here what you do, you create a separate folder for your project, and then you give some name to your project. Your project name is always a relevant name. Whatever project you are going to do, you give some relevant name to your project. Here I am giving a name demo for my project, demo 1, and you have to save this project. Once you complete this step, then it will ask you to select a device for target 1. So here you have to select your microcontroller, because when you write your code, build it, and when you create an hex file, then finally you are going to upload that code into the microcontroller IC. So which controller IC you are using, you have to select it. So here there is a list of various manufacturers given. So out of which you have to select one. So I will select this microchip, and from microchip I will select 89C51. So I will click on 89C51, 8089C51. When you select it, in description box you can see the specifications for that controller. What is a memory, ROM memory, RAM memory, number of IO lines, timers, counter, interrupt, all specifications you can see in the description box. Now you simply click on OK. It will ask you for the startup file, but the startup file is not required here. You simply click on No. Now here you can see your project is created. So in the project window you can see the name of the project, that is the demo 11 is my project name, and under that there are two folders, target 1 and source group 1. Now next step is you have to go to file and click on new. So this is what is your editor where you are going to write your program. So this KEIL software you can use for writing the programs in C, assembly, C++. that is possible. So here I will write a simple code for your reference. So first instruction is my assembler directive, so that is org. This is what is a starting address. Then I will write a simple move instruction, so move a comma say some data hash 23h, and I will end my program. So this is what is my code. So once I write the code, then you have to save this. So for saving, again you go to file, or you can use this shortcut icon also, or control S you can use. So go to file and save it. Again this window will open. Here you have to give a file name, but while giving the file name you have to also give the extension. So I always give the file name same as that my project name. So here I will give demo 11 dot. Here I am writing an assembly level language program, so my extension is .asm. If you are writing a C program, your extension is .c. Okay, so with this you have to save the file. Now see, once you save your file, here you can see the name of your file, that is a demo11.asm. And if you see the code, the colors are changed now. Your instructions, they are shown in the blue color and your operands are in red color. So that will change here once you save your file. Now once you save it, now you have to add this file into the source group 1. So for that you have to right click on source group 1. Here there are various options, out of which you have to click on add existing files to group source group 1. Then here you have to search for your file, that is a demo 11. You select it, demo11.asm. You add it and close this window. And now if you expand this source group 1, you can see here that your file gets added in source group 1. This is very important step, because then unless and until you add this file into the source group 1, your uh, project or the program will not get built. It will generate an error showing target not created. Okay, so this is an important step. You have to add your file in source group 1. So once you add, now your code is ready. Now you can build your code. So for building, here there is a icon for build, or you can use the shortcut also, F7 key. I will use this. So just click on build. Now once you build, if there are any errors, syntax errors in your code, that will be shown in the build output window. But here in this code there are no errors, so it is showing 0 error, 0 warning. So basically your code is ready to debug. Okay, now how to debug? For that you have to go to the debug section and click on start and stop debug. Okay, then the one window will pop up, evaluation mode running with code size limit 2k. So you just click on OK, no problem, and this is what is your debug window is. Now here in the debug window on the left hand side, you can see all the registers of your selected controller. Here we have selected 89C51 microcontroller. So all the registers R0 to R7 of the controller, accumulator, register B, the stack pointer, maximum position of stack pointer, DPTR, data pointer register, program counter, and PSW, that is all flags register, that is the status of all flags, that will be shown on this left hand side window, which is in register window. Okay, so when you want to debug this, then here there are two options. You have either use F11, which is a step 1 line, or you can go with F10, that is a step over. I always use this F10 step over for debugging my program. So I will show you how to debug. So just press F10. So here I have written only one line, move a comma hash 23. So my 23 data will be moved to accumulator. So see here, my accumulator is loaded with 23 and my program is end. So this is what is a simple debugging. So you can debug your entire code like this, and you can check the contents of accumulator, content of all the registers in this register window. That is possible. Now another option is, if you want to check the memory location, then here you have a view icon. So in view icon, if you see there are various options available. So in that you have a memory windows. In memory windows there are four memory windows, so you can open any one memory window. Okay, whenever you want to access any data, or if you want to deal with a memory, you have to go for that memory window. So I will open this memory window. So see here, this is my memory window I have opened, and whenever I want to deal with some address, memory address, if you are using an internal RAM memory, then you have to give the address by D colon and some memory location, whatever you want to access, then it will show you all the address locations from 30h. Okay, if you want to deal with an external memory, then in that case, instead of D colon you have to write X colon. Okay, and then you press enter, then it will show you, suppose my external memory's address is say X colon, I want to access say memory location 3000h, then it will show you that X represent it is external memory, you are accessing the external memory. And if you want to access the code memory, okay, or a program memory, then you have to use C colon in this case. Okay, so if you write give a C colon and if you give some address, then it will show you the memory location from ROM. So depending upon which memory location you are accessing, you have to write the address in this memory window. Okay, so likewise you can use the memory window. So here you can give your data for simulation purpose. Then in the view window only, window, you have a serial window. For 89C51 it has a UART1. So this is a UART1 window where you can check your serial communication output. Then you have a analysis window. In analysis window you have a logic analyzer. So in the logic analyzer you can check the time delay. So here this is what is a analyzer window is. So whenever you use go for any delay calculation, or whenever you go for any timer programming, then in that case you can check your square wave output and you can measure the delay using this logic analyzer window. So this is what is about the view option. Then we have peripheral. In peripheral we have a different IO ports. So for 8089C51 there are four ports. So this is a port 0, then you have a port 1, then you have port 2 and port 3. So there are total 4 IO ports available in 89C51. So if you want to check the output on the port, then you can check it on this any port, any parallel port 0, 1, 2, 3 as per your program. So by default the position of all ports is 0xFF, that means all are 1111 initially. Okay, then next in the peripherals only you have a interrupt window or an entire interrupt system. So all interrupt sources, their vectored addresses, their request, enable priorities, all information you can check in this interrupt system when you are dealing with an interrupt. Then you have a serial channel is there. So which serial mode you have selected, that you can see here. What is the baud rate selected, and that also you can check, and the other bits related to the serial communication you can check in the serial channel when you deal with serial communication. And finally you have a timer. So there are two timers in 8051 microcontroller, that is timer 0 and timer 1. So in both these timers you can check the various register status, whether your timer is run in the running mode or it is in the stop mode, what is the tcon, what is tmod. So all status of different registers along with the timer mode you can check in this timer window. So basically all these options are available in this debug mode in 89C51. Okay, and whenever you don't want to go for a single stepping operation, if you want to perform or if you want to run your code directly, then there is a option. So this is a run, or the shortcut is F5. So if you press this, then immediately your entire program will start running and it will generate a proper output. Okay, so this is how basically you can use the KEIL software. Then in the debug session you have one more option, that is adding a breakpoints. So if there are some loops, then in that case you can also go for inserting the breakpoint. Okay, so breakpoint option is also there, which you can also use as per your application. So this is what all about this software. Then one more important point is, when you come out of debug section, then again you click on debug and click on start and stop debug. Now once you do all these things, now if you want to generate the hex file, then you have to right click on target one. Here there is a option for target one. This window will open. So in many application you have to set this frequency, crystal frequency, because we are dealing with 11.0592 megahertz. So you change this frequency, because if the frequency is not changed, it will generate a wrong output, especially for the delays. Therefore you have to change this without fail, that is 11.0592, and then you click on output, and here there is option create hex file. So you just click in the box and click on OK. Once you do this, again you have to rebuild your program. Okay, once you rebuild, now it will generate an hex file. So creating hex file from this object demo 11, that means your hex file will be generated or created in that particular folder. Okay, so wherever you have created your project, your hex file will be there, and then you can either burn your hex file into the controller, or if you want to simulate your code on Proteus, then also you can um, import that into the Proteus software. That is also possible. So this is what is basically how to use this entire KEIL. This KEIL is very user friendly and easy software. Guys, if you like my video, then please share the video with your friends, and don't forget to subscribe to my channel. Okay? Thank you guys, thank you so much.